Hi everyone, and welcome to this video. As we continue to work our way through the acids topic, we are going to be turning our attention away from acids and alkalis for a second and thinking about pure water. Now water, actually, believe it or not, is quite an interesting chemical. Its melting point and boiling point are quite low at 0 and at 100. The melting point at 0 and the boiling point at 100. But given the size that water is, which is quite a small chemical, quite a small molecule, that melting point and boiling point is actually really high for what it should be. And so when we think about water, we often think of it as being covalent, of being molecular, and it is, there's no doubt about that. But one of the things you'll have learned when you were very young is that water and electricity is a really bad mixture, and that's because water can conduct some electricity. So there's lots of reasons why that might be the case. We might consider that there's impurities present in the water, that maybe the copper pipes that bring the water into the house, or the minerals that are naturally dissolved in our water, they're creating the presence of ions, which is what's required for a solution to conduct electricity, and that would be correct. But even if we purify water, if we remove every single ion that's present in it, what happens with water is something quite unusual, because although it is covalent, it's actually able to break itself down. It's called dissociation, and by doing this process of dissociation, what happens is water can become ions, and it can become the two ions that we met in the last video, which is the H plus ion, which is present in all acids, and the OH minus ion, which is present in all alkalis. But the truth is that they're both present in water. Okay, now it says they're a very small population of the molecules in a volume of water break apart into ions, and that's true. It's one in around about 10 million. One in every 10 million water molecules will break apart and form these hydrogen ions and hydroxide ions. But what you'll notice is that the quantity has to be 1 to 1. So this idea that H plus and OH minus, they join together, they make two H's and an O, which is water. So the idea of pure water is not that there are no ions at all. It's not that there are no H plus ions or no OH minus ions. It's that the number of H plus and OH minus ions are actually equal. And that's a really key idea as we move forward. So this picture here demonstrates the point that we were making, which is that water is formed when two hydrogen atoms share electrons with one oxygen atom to form this angular shaped water molecule that we've met many times throughout our chemistry studies so far. So this water molecule that we see here, formed by the sharing of these electrons. Now, what can happen, and what does happen, is that some of these water molecules will dissociate, they'll break apart. Now you'll notice this arrow that we have here on the screen is going in both directions. That's quite an important idea, because when water molecules are breaking apart to form the hydrogen ion here and the hydroxide ion here, you notice that the shared electron has stayed over here, which makes this negative, leaving no electrons at all in our hydrogen, making it positive. What happens is, if one breaks apart, two of these will actually join back together to turn back into a water molecule. And so the quantity that's present kind of stays the same. Every time a water molecule breaks apart to form some ions join together to form a molecule. And this is happening not very much when it comes to water molecules. Remember, we said that around 1 in every 10 million water molecules that are present are going to break apart or dissociate to form these hydrogen and hydroxide ions. So the vast majority of these water molecules stay as being molecules, and some of them are going to break apart to form ions. And that's what leads to even the purest water sample that we can have still being able to conduct electricity, even a little, okay? And it's the presence of some ions. The idea is really simple. The more ions that are present, the better the solution or the liquid will conduct electricity. In this case, pure water, although it will conduct because there are some ions present, is a very poor conductor because there are very, very few ions present. So let's think about this in terms of acids, alkalis and neutral. So you can see our heading here on the screen of neutral substances. So water is the most obvious example of a neutral substance, but what does that actually mean? Well, it comes back to these ions. We said in the last video that we can define an acid or an alkali now not just by their pH like we did in S2, but by thinking about the quantity of hydrogen or hydroxide ions compared to pure water. So what are we comparing them to? Well, in water, there's a really simple idea. Every water molecule breaks apart to form one hydrogen and one hydroxide ion. So no matter how many break apart, whether that be 10 million or whether it be billions and billions or moles of them, as we talk about in chemistry, there is always going to be an equal quantity, an equal number of hydrogen and hydroxide ions, and that is what makes a solution neutral. That's what gives the solution a pH of 7. So our definition for a neutral solution is actually any solution in which the quantity of hydrogen and hydroxide ions are the same. Okay, and that's because every time one breaks down, it forms one of each. So on the screen here you can see a visual kind of summary, a visual representation that is really important that we have in our notes, which demonstrates the way in which these ions interact with one another in order to give us pH. So when we think about going from the pH scale at the bottom end at pH 1, which is our acids are going to have a really high concentration of hydrogen ions and a very low concentration of hydroxide ions. When we go to the middle, which is water, remember the thing we're comparing our acid to, our water has to have, to be pH 7, has to have an equal quantity. So any solution where there's more hydrogen than hydroxide will be an acid. On the flip side, if we go above pH 7 and we go up towards pH 14, you can start to see that the blue side, the hydroxide ions in this diagram, start to overtake. So any solution with a hydroxide ion concentration greater than that of pure water, which is to say that if you've got more hydroxide than hydrogen, then you're going to have an alkali. And so that leads us to be able to define an acid, an alkali, and a neutral solution based on the relationship between these ions. So to summarize, to finish off for this video, all solutions containing both hydrogen and hydroxide ions is really important. It's not that acids contain hydrogen and alkalis contain hydroxide. They both contain both. Acids, however, have more hydrogen ions than hydroxide ions. On the flip side, alkalis have more hydroxide ions than hydrogen ions. And finally, a neutral substance has an equal number of hydrogen and hydroxide ions. One final thing actually before we finish this one video off is the effect that water has on an acid or an alkali. So this is actually revisiting something that we learned about in S2, and it's a really simple idea of diluting. So when we dilute an acid or an alkali, what we're doing is we're adding more water to it in the same way you would if you were making a cup of diluting juice. So you would start off with your concentrated orange or blackcurrant juice, and you would add water until it got to the sort of concentration, the strength is the word that you would often think of, that concentration of juice that suits your tastes. So an acid, when it's diluted, the concentration of the hydrogen ions reduces because what you're doing is you're adding in more water into there. So the concentration of everything is reducing down. So as a result, what happens, and this is something that we learned in S2, but we can now start to think about it in terms of ions, what we have to know is that the pH will increase for an acid. Remember, an acid is less than 7 in its pH. So as we dilute it, it will increase, but it will only ever increase towards 7. You can't pass 7 because to pass 7, it would have to have more hydroxide ions than hydrogen ions. And because water always has an equal quantity, adding water to it can never reach that point. The last line that you see on the screen here is just the exact opposite. You start with an alkali. An alkali has an hydroxide ion concentration which is greater than its hydrogen ion concentration, but as we add water, which contains equal quantities of both, the difference is reduced as that goes on, and so what happens is the pH is going to decrease. Remember, pH of an alkali is above 7, and so will decrease towards 7, but just like previously, it can never go past that point. It can never go past 7 because it's unable to shift that balance. So here's an opportunity for you to answer some questions based on the knowledge that you've gained through this video. So we'll go through them one at a time, and then we're going to pause the video to give you a chance to answer them, and then if you continue the video to the end, you'll get the answers to the questions. So the first question is, what ion does an acid have an excess of? And then what ion does an alkali have an excess of? The third question is, why is pure water neutral? Now, what I don't want for this one is because it has a pH of 7. I want you to link it back to the ions. Okay, it has to be linked back to the ions. It's a National 5 chemistry question. So why is pure water neutral in terms of the ions? You've got two acids to compare, one with a pH of 4, one with a pH of 2. You're asked which has a higher concentration of hydrogen ions. An alkali with a pH of 14 and one with 11, which of them has a higher concentration of hydroxide ions? And lastly, when an acid or an alkali is diluted, what happens to the pH? Okay, so pause the video now, take your time, answer these questions, go back and re-watch parts of the video, check your notes, and then if you continue on to the end of the video, you'll be able to see the answers to the questions and check how you've got on. Okay, so let's have a look at the answers to these questions. So the first question was, what ion does an acid have an excess of? That's the hydrogen ion, or H+. You would accept the word hydrogen or H+ as the formula given there. What ion does alkali have an excess of? So OH- is the formula, and we would also accept its name, which is hydroxide. Why is pure water neutral? Now, I did say I want this to be in terms of the ions, and that's because the amount, the concentration, the quantity, whatever kind of word we're using in there, but it's the idea that the hydrogen and hydroxide ions are equal in their quantity, equal in their concentration, equal in their number. Okay, the second set of questions, the last three, the first one is comparison of acid A with a pH of 4 and acid B with a pH of 2, which has a higher concentration of hydrogen ions. So pH 2 is more acidic than pH 4. Remember, the further away from 7, the more acidic it's going to be. The lower down that number is, the more acidic. So in this case, it is acid B that is more acidic and therefore has a higher concentration of hydrogen ions. Similarly, we're comparing the pH of 14 with 11. The further from 7, the more alkaline it is. So in this case, pH 14 is higher than pH 11 and therefore is more alkaline, and therefore alkali A has a higher concentration of hydroxide ions. And the last question, when an acid or an alkali is diluted, what happens to the pH? Something we learned back in S2, but we need to make sure that we still know now, is that the pH will increase to 7. Okay, remember something really important, pH, whenever we talk about pH, whenever we answer questions about pH, pH is a number. So if you're asked what happens to the pH, there is only ever going to be one of three answers. A number will either go up, go down, or stay the same. It can't do anything else. pHs can't turn green, they can't go red, orange, blue, they can't be acids, they can't be alkalis. pH is a number, and when we answer a question about a number, we need to describe it correctly. Okay, I hope you found this video useful. If there is any questions or anything you're not sure about, feel free to reach out and ask your teacher. Make sure that you've gone through this video and taken the appropriate notes wherever you see the note symbol. And if there's anything at all that you're unsure of, reach out and ask for help. We'd be more than happy to go over anything that you need to go over. Okay, have a great day. Thanks.